for instance, the course model or partner model, and it can filter it, properly and manage its state properly to have different views be listening to different states and stuff like that. And the best part about MVVM is that you can test the view model, which is great, right? You can test, sort of poke at it, give it different inputs, give it, different scenarios, and just test that, make sure that the state is correct. Because if the state is correct, the rest of it should be correct. And so that's great. But now we don't want to just look at how can we solve today's requirements. We kind of want to look at, okay, we solved when we looked at before, like these were our requirements, we addressed them, but then 6 months later we have to rewrite the entire code. Well, do we want to do that again? No. So how can we better address this? What are our potential future requirements? So one of the biggest future requirements is we're going to be hiring more people. So we want to hire great engineers like you guys, right? So insert shameless plug here, we're hiring. And we also want to look at potentially having this sort of tiered developer model, which moves away from just having mobile engineers, right? We don't want to just have, we want to have a mobile core engineer, which develops our mobile app, our core app, and then we want to have embedded engineers on feature teams in the site, so that the feature teams on the site, for instance, video player or assessments or identity verification teams, they can own their features, but cross-platform. They're the experts of that feature. We shouldn't be having mobile engineers trying to mimic their feature. They should own their feature. And then we also want to potentially be able to have partner institutions also develop on our platform, right? So partners, we work really closely with our partner universities to develop content. They might have some things to say as to what they want in our mobile apps. And so we want to sort of think about how can we design an architecture to allow this to happen. And the biggest part for this is sort of we need some more abstraction. Right? So if you go back into MVVM, you look at how do views essentially, or different screens, if you want to think of it that way, talk to each other. Well, they have to sort of know about each other, right? So we started questioning that, right? We wanted to say, can we have screens talk to each other without actually knowing about each other? Because then that way you can abstract it properly, so you can have external developers or developers that just sort of work in their own little sandbox and don't necessarily need to know about the details of how you implement your view and your view controller and stuff like that. Just need to worry about myself and sort of define an interface to sort of go with how you can get called and how you call out. Right, so that's the biggest key here is not just more developers, not just more testing, though those things are great too. We'll talk about that in a bit, but also about abstraction. So one of our requirements would be to have some more abstraction. So there's a lot of different architectures out there. You can sort of read them all, or do your own Google searches. But really, one of the biggest influences we had was an architecture called Viper. So this is an architecture actually developed by Mutual Mobile. The link to their page and the reading is there. I'll make the slides publicly available. So you guys should go ahead and read it. I won't go too much into it, more about how we interpreted it, but you guys should definitely read it. It's a great read, and sort of grab what you want out of it. We grabbed the essences that we want out of it. And so we sort of said, okay, how can we now progress from what MVVM, which was a valid option to use, to this thing called Viper, which I'll talk about. So what Viper does is it separates things out even a little bit more, so to add a little bit of better testing as well as some abstraction, which allowed us to go into a little bit more of satisfying the requirements that we want. So the biggest thing here is that it has something called a view, which has a little bit of more logic in it. So the view sort of manages its own state. A view might have animation states or stuff like that, but it should process its own state independently of a controller or a view model in this case. And so the view still listens to state, but it manages its own internal states as well. And then we have something called a presenter. And what the presenter is really, it is also the view model. The view listens to the presenter as a view model. The view listens to the presenter states to get updates on what it should be showing. But the presenter also does essentially the other processing that the view shouldn't need to take care of. So if the view has any sort of clicks or things like that, the presenter is the one that sort of handles it and either passes off through state changes, or it goes into data to sort of come back up. And then we have something called an interactor, which is sort of like the big data part of the view model. So the view model before was sort of handling user interaction type stuff as well as doing data stuff. But the interactor sort of now we separate out to just be handling the data information. So for things like if you need to fetch a URL for a given ID, that's when the interactor comes into play. So it sort of just isolates out the data part. And then we have something called a data manager, and this guy's the one that sort of handles all the underlying parts, whether it be you need to check the cache, whether it is you need to check your persistence on disk, or whether it is you need to make a network request. That's all in the data manager. And so this was great for us for two big reasons. The first one is you can actually unit test the presenter and the interactor, since they are both just objects. The presenter, you can sort of just test different inputs. You just test the view model just like you would test the view model before. But now you can also test the better data side of it, which is the interactor is also just an object, and you can test that given certain calls that it would just return you the correct entity that it works with. And so this was great plus, better testing, but it still didn't solve the abstraction part, which is how can we abstract away some of the details so that you don't need to worry about it and we can have those three-tier developers that we were talking about. So if you go back to Viper, let's cut away the color diagrams and sort of like go to the drawing board, and I'll explain to you how the process we went about to how we separate this. So this is Viper as it is in the article. This is Coursera Viper, which is very much just the previous slide before. We have a view which talks to the presenter, which talks to the interactor, and a data manager. And we have something called a flow controller, which you can think of as just a router. And I think that was one of the biggest things about Viper was if you think about it, it's really close to MVVM. It's just it separates out a little bit of the data from the operations with the view operations, and then it also separates out the routing away from the controller or the view model essentially. And what we want to do here is we looked at this and said, okay, great. So routing was the problem with MVVM before. So how can we make this better? Well, let's move the router down into a level. And since we've been drawing a lot of boxes, why not draw some more boxes? And draw a box around this for now. And say, this is sort of makes sense in this category. And if you look at the above diagram, we can say, okay, the view and the presenter are very closely related. This is very much what you say the front end side. This is very much what the user sees. You have your screen and you sort of have your interaction handlings and stuff like that. So let's call that, let's draw a box around that and say these two are really closely related. And then, of course, then the last two, which is the interactor and the data manager, which deals with the data side of it. So if you think web, you can almost think of it as there's like the front end and the back end of your mobile app. And then the bottom is sort of like the abstraction for the core fundamentals that you sort of need. So this led us into something, a large, heated talk for like about 2 months on what we want to call modules. So this thing called modules is we want to be able to, the concept under modules is we want to be able to create modules and have developers work with this concept of modules and only need to worry about the module that they're in, right? So if you abstract it enough, it's just a box. You say, I just need to care about what's in my box. I don't really necessarily care about what's in your box. You just need to give me a means of how to call you or initiate you or whatever it is. And so going back to the previous diagrams, let's add some color back in. We decided to put some names on it to make it a little bit easier. So if you look at the front end stuff, we decided to call that a feature module, right? So this makes sense, right? A feature is sort of like a user scenario. Watching a video, taking a quiz, verifying your identity. These are sort of user scenarios. These are all feature modules. And so within the feature module, you need to worry about the front-end screens that you need to worry about. For instance, for a quiz, you might have 1 or 2 screens about different types of quizzes. For a video player, you might have 1 or 2 different types of video players. But essentially, it's sort of all sort of modularized in there. And then you have something what we call the data manager, which deals with the data aspect. This is things like dealing with our course objects or with our partner objects or whatever it is. You might have different data modules, and you might have feature modules that don't need data, right? Some feature modules don't need data. Some feature modules can share data modules. A data module might be used by 3 or 4 or 5 different feature modules. And so the modularizing here makes sense. And then we have something called what we call core or foundation, which is sort of like the magic that ties all these modules together. You can develop your feature module and data module or just your feature module, and you develop that all on top of core. And then when you submit it to us, core is the one that sort of ties all the modules together. And there's different ways of doing that. I'll talk a little bit about how we thought about doing this. But if you look at this is great because now you can develop 2 feature modules independently in parallel without need to worry about each other. We might have an embedded engineer, working on video player module, and you might have another embedded engineer working on a quiz module, and we might have an instructor working on some fancy click drag, experiment that they're working on, and they're all developing it independent of each other because they don't need to depend on each other. They just need to depend on core. And so they can develop whatever it is that they have inside, right? You might have multiple presenters with multiple views and a flow controller goes with it. But essentially, the only thing that you need to do is sort of define a module API that sort of says, hey, this is how you call me. And I'll talk a little bit more about that in a more Android-specific way in a second. And if you need to call out, you sort of define what does it take to call me. And once you call out, you go ahead and use Core's global router. And we decided to use a URL scheme, registering what URLs you respond to. And that way you can sort of call into other modules without having them actually be there. And this way you can sort of say, okay, on the video module, I'm done. I just want to, once someone clicks on their quiz or something, then you say, okay, hey, Core, go launch whatever responds to this quiz URL, right? And so then when it comes time to compile down these apps, we get these feature modules, and we get our video module from the video team, we get our quiz module from the quiz team, and they both respond to these URLs, and then we put it all together. It links up dynamically, which works out really nicely. So this is all great, very high level and abstract. So let's talk a little bit more about Android specific. How does this actually work in Android? So there's two sort of ways that we wanted to implement this. So in Android, there's activities and fragments. We looked at some other means, but I just want to stick with activities and fragments for now. Let's assume that's what we're using. So a module can sort of consist of either purely just fragments, which are the fragment views, or actually that'll be the next slide. So if you have a module that's purely just fragments, you get the activity passed in to your module, and then that way we know that you're just dealing with fragments, and then you just use that to go ahead and swap out your fragments. And once you're inside your module, you can sort of manage that yourself or how you see fit. And then the other way is if your module has actually an activity by itself. And if that's the case, then we sort of hand off control to you, and you sort of deal with the view fragments that you have to deal with yourself. So these are the two different types of modules we have on Android. And this all can be a little bit confusing. Please let me know if you have questions. I talk kind of fast sometimes. But let's go through a more explicit example to maybe help how the sort of data flow comes into play. So I talked a lot about the video module, so let's go ahead and go back to the video module. So let's say you have a video feature module. So this is our video player, or soon to be released video player. You guys get a sneak peek. And what happens when a user presses play, right, in this new so-called architecture? So the user presses play, so this goes into the video view fragment that registers the play. But the view is supposed to be really dumb, it doesn't handle the user interaction. So what happens is it goes ahead and calls the presenter and says, hey presenter, I don't know what happened, but this button was pressed, right? And the presenter says, great, I know exactly what happened. I need to go ahead and tell this video player to change its state from pause to playing. The video player comes back, this is the way we implemented our video player. And the video player comes back and says, great, I am now playing. And the presenter says, great, I'm going to update my state from pause to playing. And once it updates its state, the video view is subscribed to that and says, oh, there's a state change. So now I need to update my view from a play button to a pause button. So that's essentially what happens for the feature module. This is how the data flow works. So let's go into a little bit more of a contrived example that requires the data module. So let's say the user presses the next button. So for us, when a user presses the next button, we have all the video IDs, and we need to make an API call to get the URLs for that. And so this requires some data fetching. So similar to the last one, user presses button, the video view says, well, I don't know what happened, this button was pressed. Presenter says, great, I know exactly what to do. I need to go fetch a URL for this given ID. So it goes into the interactor and says, hey, interactor, I don't really care how you do this, but please give me a URL for this. ID, and the video player interactor says, great, hey data manager, give me this URL. I want you to go ahead and do your thing, which the data manager, if you forgot, it's the one that checks the cache and checks the persistence and checks, and if necessary, also makes a network call. But essentially what it'll do is it's reliable and it does come back with some data. And it passes that data back up to the interactor, and the interactor says, great, I have this now. Hey, hey presenter, I have this data that you asked for. The presenter says, great, now I need to play the video, this new URL that I was just given. And the video player again comes back and says, hey, by the way, I'm now in the playing state. And the video player then updates its state, which the view says, hey, look, a state update. And then it updates its view to correspond to what just happened. So there's a lot of abstraction here, and so which means it has a little bit more overhead. But we think that this sort of fits the requirements that what we want to be addressing a potentially year from now. So if you go back to like our requirements, it's the sort of modules is very friendly for multiple developers. It doesn't matter how many developers you add. Each one you can have, we have 100 developers. Well, let's have 100 feature modules. Go ahead and work on that. Or you can work within a feature module that works too. We can have lots of features. corresponding with all the different feature modules. It's great for testing because you can test not only the front end part, which is the presenter, we can also test the data part. And then it also adds enough abstraction so that other mobile engineers that work on a platform only need to care about their module, right? They only need to care about how do I handle my use cases, and then when I'm done with my use cases, just hand it off and let other people work on that. But what's important here is to note that all these different architectures, and there's plenty of others out there, sort of fit for different requirements and needs. So you should sort of look at where you guys are in your app or your life cycle, and sort of say like, is this sufficient for what I need? And also maybe look at, is this sufficient 6 months from now, right? 6 months ago we launched our first Android app, and already we're sort of rewriting the whole thing. So we kind of want to take care of that, and so to put it into a little bit of a summary, you have these different architectures and stuff like that, and some are better for use cases. And when I say like for MVC, it's kind of hard to test. I put an asterisk there because it really does depend on how you sort of implement it. MVCs are, is a great architecture, and I think the main problem here is just that it's very easy to sort of overwhelm it with a lot of things, and so it gets a little bit harder to sort of deal with. But it's up to the programmer. If you guys are really, really great programmers and are really hardcore, code reviewers, you can sort of still keep things abstracted and stuff like that. So really just look at, everything's a trade-off. So just really look at, is the extra abstraction and extra overhead really worth the benefit that I'm getting out of it? And so you sort of just need to sort of decide that for yourselves, but sort of some of the thoughts that we had here. And with that, I'd like to thank everyone for their time. And open up for about maybe 5 minutes of questions, and we'll stick around after for any sort of questions you have or diving into code. There was no code here, but if you want to see more, I'll be around after. But any initial questions?
How many lines of code do you have when you switched between different architectures?
So we only really switched from MVC to what we're doing now, but we had a decent amount. I think one of our controllers was about 1,000 lines of code, and that was just one of them. And so it ended up doing a little bit too much, and so we already started trying to, because we know we have interns every 3 months, right? The interns that'll be the first sign, right? An intern will come on and then open up this up and be like, what the heck? Like, didn't you guys just launch? Like, how is there so much like crap in here? So that was sort of like the first sign for us. And yeah, that's basically it. I don't know, did I answer your question?
Yeah, it's surprising, right?
Surprised us too.
1,000 lines is very normal for a controller file, in my experience. It's surprising me that you guys are looking to switch it.
Yeah, I mean, you could say we're a little bit ahead of ourselves, but I mean, if you think about, if we wanted to scale properly, like think about what happens if we had 50 developers, if we had other developers working for us, how we can do this. And we also have a QA tester who's been bugging us about our unit tests ever since day one. We've had no unit tests when we first launched. And then when we started trying to look into how can we add unit tests, it became really, really kind of mucky to sort of budge. And so we just wanted to sort of handle it properly this time so that, we could have probably kept going for another year. But we wanted to kind of address the root of the problem. And that's actually where Paul came in. He's seen this happen. He sort of recognized the problem and was like, look, guys, we should address this now while we have the resources to do so. But yeah.
How do you make money?
How do we make money?
Yeah, I mean, if everything is free.
Yeah, so content will always be free here at Coursera. We're all about universal access, but we do have a business model on top of that. Is how we stay a sustainable company. We have two ways right now of making money. Each of the individual courses, if the university signs up for it, also has something called verify certificates, which we call signature track. And so what that means is we verify your identity as you take the course so that we and the partner university that we're partnered with will verify that you are who you said you are when you complete the course. So it's sort of a certification on top of that. And then the other aspect of that is the specializations, which I mentioned before. So specializations, although the courses themselves are free, the program itself is not. Specializations is a group of courses. For instance, our Android specialization, you take 3 Android courses. Each one needs to be verified, and so that's like $50 each. And then at the very end, you have a capstone project, which also is, it's like $100, and that's in partner with Google and stuff like that. So we offer resources for that. But that's the business model we have now.
I'm curious since like the modules seem very like isolated, independent, how do you guys structure your packages in your project? Is it like each module is an individual package in the project?
Yeah, so each module is basically like an Android library. And so there comes a time when you have like sort of a lot of libraries, but that's the main app at the very end, right? When you're developing yourself, let's say you're maybe an external developer, you really only get the core library and maybe a skeleton library, which we call modules, and you sort of work with that. Once we bring it all together, the core team has to deal with all those libraries, and then we'll try to patch them all together and try to make it as efficient as possible. But that's a problem. We want to offload that problem to the core team and not have the external developers worry about it.
So how do you guys do continuous integration?
Like integration testing.
Yeah.
So right now, we haven't yet solved the problem, I would say, but the way we're looking at it right now is like we're looking into other tools, for instance, like Roboelectric, and hosting our own Travis server to start seeing like what can be done there. So currently our testing just mainly consists of unit testing, and integration is something that our QA is working on too, with this, especially with these new modules on how to do that. But if you have suggestions, we're open to hearing.
Anything about open sourcing this back into?
Yeah, so well, maybe not our project right here, but
just the architecture.
yeah. So the Viper to do article has an iOS open source project, but that's out of date since iOS Xcode 6 came out and Swift came out. And so actually a couple of us, myself and Mustafa, one of the iOS leads here, is thinking of creating our own project, or like a Viper to-do. So what Viper did is they built a to-do application using that architecture as a sample app. And so since it's a little bit out of date, I had the ambition actually to create that project this weekend, but then things got kind of busy. And so, but hold it to us. Keep sending us reminders. We'll go ahead and we can implement that and make that open source that too. How about one more question, and then I'll be around for the entire duration. So come find me after. I think you were waiting.
Okay. So I'm also curious about the testing strategy. So you mentioned the Roboelectric. Do you guys use Roboelectric to do unit tests? And also, second question is, do you do like the UI automation testing for Android?
Yeah, so Roboelectric is really, when we started looking into Roboelectric, it's really for the UI automated part. The unit testing, since Roboelectric does have it, it's also what we're using right now. But the strategy itself, I wouldn't say is perfect or fully developed yet. Yeah, that's our current state of the world. But yeah. Okay, so we're gonna move on with the talk, but I will be here. Please come find me, ask me any questions, or if you want to dive into code. I'm happy to do so too. But we want to move on to the next talk, which is by Payam, one of the designers here. He's going to talk a lot about design here at Coursera. Thanks.
Hey guys. So my name is Payam. I'm a designer on the mobile team. Hands for who's a designer here? Anyone? One. More than I thought. That's great. Cool. So I'm going to be talking about something that is going to sound really different from what Ishan just talked about, but in some ways is fundamentally very similar, which is about frameworks. And so I joined Coursera just over 2 years ago, and at that time I was the second designer that joined the company. We were about 20-something people. Now we're, I think, over 150. And just about a year after that, a year ago, Ishan, Paul, and I started to work on the first version of Coursera's mobile app. And at this point, we had no mobile offering at all. Taking a course on your mobile device was an absolute nightmare. And so it was just the three of us in this corner of the office, just working as fast as we could, trying to put our content in a format, in a native app that our users could access on their mobile devices. And this is something that they were begging us for. So our priority at that time was all about giving them access to this content in a way that they can take it with them anywhere. And at this time, because it was just the three of us, we didn't have the manpower to necessarily support every single feature of the product or to round off all the rough edges of the experience. So we relied on a lot of frameworks for iOS, Android, and Bootstrap for web to get our product shipped and get it out and in the hands of users. And here we are, just over a year later, and we've got a bigger, better, stronger team, and we have bigger ambitions. And our goal for this next evolution of the app is to move beyond just providing access to our content and actually create an experience that delights users and is immersive. So we still rely heavily on frameworks where it makes sense to help us move faster. But we're also starting to create these custom experiences that create really unique moments, these special moments that are unique to our product experience. And this also doesn't mean that designers can just sit in a room and imagine anything they want and throw it over a wall to engineers and expect engineers to bend over backwards, maybe even writing some really hacky code, just to fulfill that design pixel for pixel. But it means that designers have to have a really deep understanding of this medium that they're working with, whether it's web or Android or iOS. And so it means really understanding the nature of the medium so you know when to push for something that might be more unique and maybe takes more work, and when to hold back and just rely on something that already exists and is going to help us move faster and solve the next big problem. So over the lifetime of our team, we found really interesting and effective ways to bridge the gap between designers and engineers. And I want to share some of that with you today. So one of the first things we started to realize was really helpful was for all of us to speak the same language. So there was a time where I was just naming my icons whatever I kind of thought made sense, and I was naming my colors by just generic names. And one of our interns one day just finally smacked me in the head and kind of sat me down and taught me how engineers think about it. So for example, for naming hierarchies, going from very generic terms to more specific terms helped us organize everything much more effectively. Creating abstractions for colors helped us refer to, when we say a certain color, we knew what success meant, we knew what warning meant. So as I started to learn these, we started to harmonize the way in which we refer to all these different kinds of abstractions around typography and icon classes and components and all different kinds of views. So this also made cross-functional conversations a lot more fluid. And as designers, we really try to communicate our work in a way in which the hard work we put into every little detail, every little decision, doesn't get lost or diluted or misinterpreted in that communication from mocks to code. So it means we have to detail out our specs in a way in which it doesn't just look the way that we want it to look, when it goes beyond what the user is going to see. We really try to inform the specs with underlying structures and logic that we think about as designers. We were seeing that a lot of that was getting lost when you just flatten something into a PNG and add it to Jira or something. So this helped engineers build software in a way where it would work on multiple screens, multiple platforms, and in various states without us having to keep debugging edge cases. And this all sounds really great in theory, but in practice it's actually not very easy. There are a lot of common mistakes that I've seen designers make, and I've made every single one, so I want to share a few with you. A common way designers approach designing mocks, and this is often something that happens with designers that have just joined the team, is that they're given the task of improving a certain part of the product experience. So they'll go and do a screen cap, or they'll do a screenshot on their computer, and they'll drop the files into Photoshop, and they'll start to hack away at pixels. Taking a button from one screen and plugging it somewhere else, making a big white box over something that they want to cover with some other content, trying to figure out what font and weight and line height that is so they can put a different copy somewhere. And they'll eventually sort of land on some mock that they want to give to engineers. But this is really time intensive. And it's ineffective because it doesn't give designers a lot of control over the UI. It doesn't give them visibility into the underlying structure and the styles and the logic of how that UI was built. It's just not accurate, and it's inconsistent. Even if you make a great change in one part of your experience, it's not going to get reflected anywhere else. So another way that designers will approach doing their work is by sketching out really lo-fi wireframes early on and just kind of worry about visual design and layout later. And this is a really great way to get started. It's a really great way to get ideas out of your head and onto paper. But soon after that, it has a lot of shortcomings. You can't really get a good sense of what the user is going to experience when they're holding that product in their hand, because it's not a good place to get a sense of the color and space and grids and hierarchy and all these other things that design tools make really accessible to us. it also makes it really hard to iterate and try different ideas, because to create something all over again, you basically have to sketch that entire screen by hand from scratch, and it kind of prevents you from even wanting to experiment with multiple ideas. Whereas in a drawing tool, you just duplicate the screen, change one tiny aspect of it, and you can compare multiple ideas side by side. And eventually, you're still going to have to worry about somehow turning this thing into a realistic UI that you can show in design reviews, you can do user testing with, you can show to engineers, which leads to designing UI from scratch, which is also a huge pain, because you find yourself trying to make the same decisions over and over again, trying to figure out what the final decision was you landed on the last time you encountered it. So you're just sitting there wondering, what's the corner radius we use for modals, or what's the gray color we use for text, what's the line height for body text, how many pixels are in a row, and what happens when you have multiple rows of text. And the questions just go on, and as we found, as you add more designers to your team, there are more of these questions popping up all the time. And we don't want to be spending our time worrying about these decisions when we can really be spending our time worrying about problems that haven't been solved yet. So probably the best approach that we've seen so far is to rely on really well-designed front-end frameworks. And these frameworks are a great starting point for helping you just at least recognize the decisions you're going to have to make at some point down the line. And engineers love these because they're a logical, well-defined set of rules that you can just follow to build your experience. But designers are a little uncomfortable with these frameworks because they're really constraining, and you feel like you can't be creative. You want to create an experience that's custom to your product, to your brand, to your tone. And so that's just one problem with frameworks. Another problem is that you run into a lot of accessibility issues. You know, a front-end framework like Bootstrap was built for engineers by engineers, and it's based in code. So while designing in code might be fine if you know exactly what you're trying to do, exactly what you're trying to create, it's really hard to come up with new ideas on the fly. And so designers either completely shy away from these frameworks and don't even give them a try, or they hack it up so much to the point that it's not a framework anymore. So, and you know, the best frameworks, even the best frameworks so far have outlined really well what individual components should look like, but haven't really given us a whole lot of guidelines around how those frameworks should fit together in the experience. And this is why we love material design. We love material design because, in our opinion, it's the most comprehensive perspective, really, on what software should look like, feel like, and what software is that we've seen so far. It uses these really great metaphors for helping us form a mental model of what this environment is that we're working in, that we're creating in. And when it gets everyone on the same page about what the logic within this environment is, you can spend less time trying to figure out what, you know, a card on top of another card means, and spend more of your energy just doing what you need to get done. So it means that as designers, we can spend less time worrying about how to design ways to convey depth and hierarchy and orientation and direction and everything else that goes into creating the mental model of the software. And we can spend more of our time actually trying to figure out what it is that our product's offering is going to do that's going to add value to people's lives. And as engineers, we can spend less time trying to hand code one-off features that someone made and spend more time solving problems that frameworks haven't solved yet. So we wanted to leverage the amount of thought and careful precision that Google's material design team put into actually creating this framework, and put that in the hands of our designers so that they would still be able to stay true to the core principles and patterns of material design, but have enough flexibility to change things around where necessary to create a custom experience. So that's enough. Oh, and one more thing was that we actually wanted to do this in a way where it was intuitive to us, where we could be effective as designers. We wanted this to be in a drawing tool, not in code. So I'm going to stop talking and actually show you guys some of the ways in which we're using material design, and also how we're structuring our design files. So I'll start first by this, I guess, template that we've been putting together. There are a lot of templates for frameworks like material design and Bootstrap and iOS. The problem with a lot of these is that they're very flat. when you are looking at a set of components, you'll look at one piece and, oh, but this, by the way, is Sketch. I can talk more about this afterwards, but it's a really great drawing tool. They'll have the components, what they look like, but they're not linked together in a way that we link components together in code. So for example, the green that you see here under this line is not in any way tied to this green, aside from the fact that they're the same hex code. And what we've done is create a set of layer styles so that they each connote a certain trait. So for example, we have a set of colors, we have a set of card layers. You know, if you looked at Android L, they have these like different z-axis cards that signify hierarchy. We have different button states. We even have, oh man, my flux is going on. Just turn that off. It's good for the eyes late at night. You guys should get it. It's a great little plug. So we have these layer styles so that you don't have to decide every single time you want to have a tooltip. You don't have to decide what opacity that black has to be. You just have to decide whether it's a dark overlay or a light overlay or a normal overlay. Or if you're trying to connote, success in something, whether it's a progress bar or some text or a button or a slider, you can just choose from that one color that you specified, and everyone can be on the same page. So, for example, let's say that for our product we use green as the color for success, but let's say that you actually wanted to use something different. So, let me actually just go down here. So. Anyone use Strava? Awesome. So Strava is this cycling app. It's really cool, but their brand color is orange, and they use orange to indicate that you're progressing in something. So you can just zoom out a bit. So if I wanted to do that, all I would have to do is have one of these things selected. Go here, and I'm calling colorblind, so I will probably mess this up. We choose orange, and now all these are orange. Everything here is orange. And you might sometimes have to do a little bit more work. So for example, this text here, you can go to the type styles and select all the text that's green, and just gonna, so you can take the text and change it to that. And with just a few easy steps, you basically have a style guide that looks exactly like your brand. And you can do all kinds of other stuff, like, for example, as you see here, we have a drop-down. Sketch's rendering is really bad, and that's one thing I hope they improve. But here, if you look at the card we have in the background, it's a Z2 card, so it looks like it's about, if you have 5 levels, it's on the 2nd level up, whereas this one here is on Z5. I can just take this and change it to a Z1. Oh man. Don't do this to me now. It's never had 2 TVs connected to it.
Nice.
So we're just with one easy step, you can go from having a card that looks like it's flat on the surface of your UI to something that's floating really high up. Oh man, it usually doesn't take this long. Anyway, you get the point. A couple of other things that are really useful. So I showed you the Z-Card one. There's also this really great plugin called Dynamic Button. And what it allows you to do is to, I'm just going to quit this and start over again. Sorry guys. So this is actually a pretty common way of using UI, where you have this object, and this is a form field, and you want to have some text in it. And the problem with most traditional templates is that you start adding a bunch of text, and you eventually get to the end of it, and it breaks the component, and then you have to go and select the background and start resizing it just to the right size. And what's great about Sketch is that it has this little thing called a dynamic button plugin, where you have this layer structure where you have the name being the top, right, bottom, and left padding of your object. And if you just press Command J, it resizes this element behind it to be whatever size you need to be. So I could just keep going and resize that object to be the size of my text. Other things that are really simple are things like changing icons. So you can just go right into this, and maybe you want to actually not have a heart here, but you want to have a place icon. And with one click, you just switch those icons. You don't have to go digging around to a folder, find an icon, and drop it in. It also means that I can go straight to my icons and say, actually, every icon that I have, I wanted to, or at least like for these icons, let's say, I want the color to be danger color. And now every instance of those icons change. So these are things that, again, like Ishan was saying, take a little bit of upfront work, but once you have them and you're trying to make quick changes on the fly, actually make it really easy. So today, we were having a conversation with some of the engineers about this one change that we had to make, and I was stressing out because I was preparing for this presentation, but I was able to put it together within just a few seconds, literally, because it was all there. It was very easy to move around. Once you understand the nature of what you're building, it becomes really easy to work within these frameworks. Something else we do, so now I'll move over to the actual product spec that we create. This is not the right one. So this is our mobile spec for our, you guys are getting a sneak peek of this. This is our mobile spec for the newest app that we're about to launch. And so we structure our files in a way where you always have this one flow view that gives you a high-level view of how the screens interact with one another. But then you also have the same components. So here I have all my colors, all my card layers, all my shades, all my fonts. So if I all of a sudden wanted to go from, oh, actually I was tweaking this earlier. So we're using Sophia here, but let's go with something that's more familiar to you guys. And just change that to Roboto here. Oh, thanks. And now everywhere in this app, all the text has been changed to Roboto. And type is another really interesting way to work with this tool, where you have all these different type classes that you can just call upon. So when we say, I'm using a headline here, everyone knows what a headline is. You don't have to go into, oh, you know, it's Roboto regular 15 with 18 line height. And one last thing that I'll cover is area highlights. So who's used the sort of Chrome DevTools? So you can sort of inspect elements and see where their bounds are. So we use content and touch bounds. So when you're looking at your spec, you can see, you know, wherever the blue is, that's what the actual bounds of these icons are, or where the text is. So it just becomes really easy to move things around. And if you hold Option, you can see the distance between objects. So I can go here, and instead of having to, you know, look at a grid or draw a box and measure it, all I do is just hold Option and hover on other objects, and it can tell me the relative spaces. So I'll just kind of stop there, and if you guys have any questions, I can still keep running through it.
What tool is this?
Sketch.
Sketch?
And we actually have really been loving Sketch because it really keeps you honest to the sort of digital software platform. It doesn't let you do things that aren't intuitive in software like Illustrator or Photoshop let you do. And it's also, it was $80, now it's $100, which means that everyone in your team, it's still much more affordable than paying $50 a month for Creative Cloud, which means that now, not only do all designers have Sketch, but all the engineers in our team have Sketch too. So when we submit our files, it's not a PDF, or it's not some, you know, some flat document. It's all the rich content is right in there. and we can dig right into it and understand really how the product's built. Yes.
So you've got the Z-axis for material design. Is that already part of Sketch, or did you do that as a template for material design?
That's something that I actually made. They made the sort of, I'll show it to you. So Google made the information about it public. So for example, they would give you this information right here. And I just put it in, saved it as a style, and now you can switch between any of these. So Z2, Z1, and I created some new styles that I thought would be useful. You guys can download this. I made it public today on my Twitter, so I'll put that up on the screen later. You guys can go and download it and check it out. And I'd love any feedback. It's a V1, and I want to iterate on it so that it's useful for all designers and developers.
Are you using this material design only for Android or for iOS too?
That's a really great question. We actually have been trying to create this sort of a hybrid design style that integrates the best of both worlds. So it feels, it doesn't feel out of place in either iOS or Android, but a lot of what we've done in the new app is informed by material design, and it's pretty consistent on both platforms. And there's still some technical constraints, like you can't do blur as easily on Android, or you can't do a Z-axis as easily on iOS, but we're hoping that as those constraints become solved, we can have an experience that's more unified on all platforms. But there have been a lot of really good ideas with Android material design that we're letting inform our iOS designs. Yeah.
When you showed your spec sheet, it didn't show like me the size of the buttons or other objects. Like, how do you have those traditional like red lines that define like what margin padding those things are, or do they have to click on it and look on the right side?
So that's a really great question too. We've actually been moving away from red lines and just using the inspector to know all that information. But the best part of it is that when, as a designer, you're really thinking about that logical way of forming your UI from the start, you can pretty much look at a box and you know if it's a 24 or 36. We don't have like a 25 pixel box. And we've moved away from red lines because we found that using Sketch, developers using Sketch is really effective in letting them just dig right into everything you want and dig out as much detail. Whereas you can only do so much with red lines.
And what about grids? Do you use grids to measure and lay out on the page?
Yeah, to some extent. We have, so for example, here on the video player that Yishin was showing earlier, I can turn on the as well. So we have some custom grids and we have some common grids. Generally, we follow the Android guidelines of 8 pixel or 8 dp increments, but there are also scenarios where we'll design these grids that, for example, say that all these icons are 20 pixels from the edges, and the padding and margin shows that here. Is that kind of what you meant?
How do you handle backward compatibility after the previous version of what you have the Z level Z part will be completely different?
I'll let you answer that question.
With some of this is product decisions, but really on Android, we really only support 4.0 plus, and so a lot of compatibility issues somewhat goes away. There are some problems with 4.2 or below or something like that. For instance, like for blur, there's in 4.2 plus, it's really easy, but 4.2 or below blur is like you have to do it manually. And iOS is similar, but I think so for Android we're 4.0 plus, and then for iOS we're moving to actually just be iOS 8 only moving forward for now, just to enable getting the product. So we're still relatively small, but backwards compatibility is something that we'll have to address too as we move forward. As we increase our team size too, we'll potentially make that, we'll have at least the resources to handle for it. But currently that's our current state of the world.
So, like for example, Z, how do you handle like 4.0 and 5.0? So 4 doesn't have the Z level card.
Yeah, so sometimes what happens is like for 4.0 or for 4.1, if things aren't available, we actually have alternative designs that sort of compensate for it. Either you take it away or you add something else, either shadows or something else to sort of, maybe not shadows for that example, but maybe for 4.0 we just don't have it, right? And so, but those are things that we come back to the design team and says, hey, look, we can't do this in this. This is what we have to work with, and they'll either iterate on it or they'll come up with something different and say, okay, maybe this is okay. Or if it's absolutely necessary, we might end up having, so let's say for blurs or something, we might have to just write our own blur library or something like that. But everything's a trade-off, and so we have to look at, okay, our Android team is like 2 people or something, so how can we actually afford to do this right now? Trade-offs.
So I'll add to that too.